This is the board delivered by Sinway. It's the characters board. It has some issues. I am running the just cars, or just chars, prog file from the prototype 3 directory, and it's displaying this. This is meant to be the test pattern at the beginning, and if I press fire, it should then be displaying the trees from Shadow of the Beast, but it's not. It's displaying a screen of what looks like the outline of the trees, but the characters data is completely bad. But it's not completely bad, but it's like this. It's not really recognizable. You can see that there's some trees, but that's the characters data. And I think what's there is basically whatever is in the RAM on power on. So if I press fire again, it will scroll, which is what the demo is meant to do, but obviously there is some serious issue here with trying to read the character definition data. So I'm going to poke around in simulation and see if I can create a similar issue as this. And then if I can find that issue in the simulation without poking around too much on the physical PCB, then hopefully that'll tell me where the physical PCB is. It could be a bad RAM, it could be bad RAMs. I'm going to see if the pattern changes of the power on and power off, because the pattern doesn't really change, I don't think. If you notice here that this here, right? If I run it again, I think it's probably identical. You see, this is meant to be the test pattern of 1, 2, 3, 4 or ABCD or something like that at the beginning. Yeah, the character data is not changing, so that means it's not really writing the character definition data, perhaps, or it's not reading properly. I don't know if it's not writing or not reading, because it's difficult to tell, because there's no way of reading back the information. And for reference, this is the working characters board that was delivered from PCBWay. So this is what the screen's meant to look like. Boot, and it waits for fire. It will then display the trees, and then if I press fire again, it scrolls. And then if I reset the Commodore 64, run it again, ding 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 ding, there you go. The test boot pattern is back again. So debugging the slightly dead board that was delivered a little while ago, I noticed when I was visually inspecting the board under magnification that U10 here was using a 74LS00 instead of a 74LS10. So when I clipped out temporarily the 00 and replaced it with the 10 by piggybacking it onto the pins that were already soldered in, I get a better test pattern, although the character definition RAMs are still not quite working, and there's an interesting observation with that, but at least this test pattern now is a little bit more correct. You can see as well that if I press fire, the outline of the trees is visible, and the rendered image is slightly better in terms of different Y positions and stuff like that. And that's because if I go to, the X position for the pixels also shows that there is data being output on a regular schedule now, and that's because if I go to U10, we can see here that one of the components for U10 was the horizontal timing and the character load timing. And actually when I was debugging this in the simulation as well, if I disabled U10, I was seeing something similar. So replacing U10 in this way was actually pretty good. But there is another issue now with the character definition RAMs. So there are three usages of the gates in U10. There's one here, and then the second one is here, which again is related to loading logic and calculation here, and the last one was feeding into here. So these deal with the timing logic, the different loads. So anyway, replacing this made it a little bit better. But however, I noticed that there's a very weird problem now. So if I switch back to the board which works, straight away we can see that we've got nice trees and stuff like that, and they scroll along. That's not an issue, because when I connected this up, the dip switches on the working board are actually correctly set to read the information that I want, and this for the scroll registers here is also connected up, so that's all fine. That's not a problem. But however, what we do have is that we have an issue now where if I enable on the non-working board, if I enable the address logic for the character definition RAMs. Oh, let's go back to the test pattern first. It makes it easier to see. So if I go back to the test pattern on boot up, we can see that we get these standard characters here. And now if I enable on the non-working board, which doesn't have video output connected, but it's still connected to the bus and everything here, if I enable, bink, short update. So this is the working board when I have the character definition dip switch, which in the schematic it is dip switch to DSW2. Okay, when I have that enabled on the non-working board, this sometimes happens. It fails to store character definition to the character RAMs. Really, really odd, right? Why is this the case? Because if I turn off the character RAMs now, there we go, and then if I reset, and then if I rerun, so on the non-working board I've turned off the eBBS selector for the character RAMs, everything else is back to normal. So it looks like there's some kind of logic contention feeding back through DSW2. If there's a logic contention feeding back, then it's going to be coming back through here and then to eBBS 5, for example. So highlight the net on that sheet there, and then highlight the net on the current sheet, bling. And the net does this. If I zoom in a little bit, we can see, just to make sure that there's no other nets. Nope, it's just this one all the way up here in the top left, and then it's the nets down here in the bottom right. So, what does it do? Well, it's used for selecting the internal or external RAMs, the address used, okay, and that can only really go one way. It does an output enable, which is here, and here on the RAMs, and the other one is that, let's go back and highlight the net again, zooming in. The only other one is that it goes into, is meant to go into U90 ding, 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 which is a 74 LS00. And it's meant to help select the individual RAMs based on the 16-bit address here. If there is a logic contention feeding back through from one of these U90s or the U42, it would feed back through and then come back through the dip switch and then interfere with the RAM selection logic for the other working board. So the way I can test this perhaps is by selecting a different line. Let's reset that. If I select a different line on DSW2, like this one, like completely different one. There we go. Okay, and if I reset, and then we run it again, and then we see what we get. I don't see any contention this time in that address, and that also seems fine, and that also seems fine too. Let's just run it again, just to be sure, on the safe side. Oh, well, let's see what. First of all, let's see what data we do have. See, the address is the EBBS at this particular point in time is being pulled low, or it should be pulled low. There shouldn't be any high information on there. So we're getting this, we're getting what looks like uninitialized character definition data, which is kind of expected, to be honest. But the character screen is there and working. So, bing, that's back to the working board. So this is interesting. So I think the hypothesis is correct. I think there is a logic contention coming either from U90 or U42, which is coming back through CHEBS5, and causing issues. So now I'm going to have to really inspect U90 and U42. And if I want to, I can see where they are on the board. So here we go. I should be able to click this, do this. Highlight part in the PCB layout. U90 is where? U90 is down here in the bottom right hand corner, and then U42 is down here in the bottom right hand corner too. Oops, wrong menu item. Highlight part, PCB layout. U42 is right next to it. So if I'm going to visually inspect these now on the board, see if there's anything really suspicious. The problem was pin 7 and this via on the circuit board. There was an overflow of solder on the solder side, not on the component side, and these two were bridged. I was checking the continuity of CHEBS5, which is coming in here. This is CHEBS5. If I zoom out a bit, there we go. This, because the hypothesis was that there was a logic contention coming back through here, and it was, or it was grounded, and pretty much it was a logic contention coming back because pin 7 on this component here, if I look at the component, it is U29. U29 pin 7. If I go to the schematic, U29 pin 7 is the output of ICA1, which is the internal address for the character definition select. Okay, either coming from the external bus or the internal character address. Okay, and it goes through these components here to demultiplex, or to choose which one based on the value of CHEBS5. So the external high bus was basically getting a logic contention with pin 7 here, and it was always being pulled high. So that explains all of the weirdness that I was seeing. So if I switch back now to the working board, bink, Right, and then if I press fire, oh, Commodore 64 is not running. Let's kill that. Let's run it again. This is the working board. Ping. Right, see. And then I press fire. Ding, ding, ding. Scroll. Everything is fine. The non-working board. Bing, bing, bing. Connect it back again. It's doing practically the same thing, apart from there's this weird stuff here. Like an overflowing timer or something. Anyway, so it's almost there. Perhaps it's one of the high address lines. I'm going to have to very carefully manually inspect all of the solder joints on the solder side and the vias to see if there's any overflow. Because if there's one, there might be another one. Anyway, so it's pretty much working now. I just need to continue on and check all of the internal addresses here to make sure that there's continuity. I don't think there's any issue now with logic contention coming through here, so I think it's one of these coming through, or maybe one of the outputs, or what. Anyway, so unfortunately, these internal buses for the character definitions are quite complex, and there's going to be a lot of checking involved. I don't think it's one of these. I checked the components already. They're good. Visually inspected, visually checked the components, and they are the right types. Because look, it's the 74LS00, which was transposed with the 74LS10 in U10. I thought maybe they had transposed one of the components, but nope. I don't know where the extra 00 came from for U10. I guess it must have been floating around on their parts bench or something, because it looked very different. Anyway, so pretty much, good progress so far with the debugging. I just need to check on these outputs here, which I'm going to do now. So 28, 35, 40, and 36, I can test the continuity that they are all discrete between all of these, and we'll see how that goes. Non-working board debugging update. So it's almost there now. So there is still a bit of a weird vertical line on all of the characters. Now, the vertical line on all the characters indicates that perhaps one of the bit planes, perhaps this bit plane here, for the character 0, because it's yellow, you can see that it's not affecting the 1, it's not really affecting the 2, it's behind. Okay, so the color is perhaps different. Anyway, so this here indicates that there is a vertical, there is at least one bit which is always being pulled high. It might be on the output, it might be on the input. However, it's a much better picture now, and I'm going to go through the reason for that in a minute. So you can see here there is a line still, there is a line here, but at least it is looking a lot better now with this non-working board. It's almost working. There's this weird artifact here on the left hand side. I'm really wondering what that is. It looks like it's picking up some timing on perhaps one of the characters, which is a really, really odd bug. It's probably another one. Maybe two more bugs. Non-working board debugging process. Almost there now. So after visually inspecting, after using the simulation to reproduce the issue observed on the PCB, on the built PCB, I noticed two things. One, setting signal 8K6D5 to be 1 and 8E6D6 to be 1 resulted in very similar visual effects as the previous issue. So now when I corrected one of the signals, when I corrected 8K6D5, which comes from one of the first RAM bit planes for the character definitions, you can see here that the 0 is almost fixed now. There is still another pixel to the left of it which hasn't been fixed yet, but basically tracing 8K6D5 in the layout tool showed me this, and when I set it to be floating high, or basically plus 5 volts, I noticed that I was getting the issue, and I could see when I zoomed in, there is this via here right next to the signal, this via here right next to this pin, and this pin is on the power net, plus 5 volts. Instantly suspected this, looked on the PCB, and I took some photos of before and after, so I could see another solder joint between here and here. Once I fixed the solder joint by reflowing it and removing some of the excessive solder and using some good quality flux, there is now good separation between these two on the PCB. There is no solder bridge anymore, and now it resulted in this fix. So now I just need to look at the other signal, which was the issue. Now the other signal was 8E6D6. 8E6D6, you can see that it goes into the shifters, so it's two signals, not even one. It's great, isn't it? Okay, go to the part, go to highlight net on the PCB layout. So this is what it's meant to look like. Again, you can follow the signal, bing, 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 bing. There's a via here. It's close to this pin, or pin. Well, this pin is the ICA. So there might be an overflow, because I'm seeing that weird effect, which looks like counting. Now, if I'm seeing counting, it might be because it's connected or a solder bridge to one of the internal addresses, and it might be this one. So it could be this down here. You see it's these other rounds here down at the bottom of the bit plane. Anyway, so we'll just see where the continuity is again, and we'll just double check the PCB once we get there. So the non-working, which seems to be working board now, debugging effort. So I visually inspected the PCB again for the other line and found that 8N6R pin 23 had a solder bridge to this via. Pin 23 is actually one of the internal address bus lines for the character definition. So when the character definition data was coming through, it was getting corrupted by the bus line data before flowing through to where it's meant to go here. So again, this via was very close to the pin. There was a solder bridge. Now, when I look at the debug boot screen, everything looks good. And now when I press fire, there you go, the tree data comes up, and now it is scrolling. So the what wasn't working board looks like it's now fixed. There were several different issues on it, but it's now good. So now I'm going to try both of these boards together, two different screens, two different layers at the same time, and see if they both work in conjunction. They should do. After debugging the second characters layer, this is what I could see. So I've enabled both layers. The first layer in front that you can see is the score panel layer, which can also scroll, but it's not in this example. And then we've got the background layer. When the tiles board and when the sprites board comes, then I can plug those in and hopefully they'll work first time. PCBware just finishing those ones off now, and they should deliver them sometime next week. So successful debugging, which is always nice to see.